Spiders are among the arachnid world's ultimate success stories, with tens of thousands of species coming in a nigh limitless array of shapes and sizes, and spread across a range that covers every continent save Antarctica. These marvels of the undergrowth abound almost everywhere one could possibly venture, thriving from the far reaches of the wilderness to the dusty corners of our own abodes. And the ubiquitous, constant presence of spiders spans not only space, but time. Spiders are not especially well represented in the fossil record, but from the somewhat limited selection of remains that have come to light, it's evident that these arachnids have existed for an extremely long time, predating the dinosaurs, the very icons of that which is ancient beyond measure, by over 100 million years. Spiders are far from the only inhabitants of the undergrowth that have stood the test of time to so astonishing a degree. Some other familiar groups, like scorpions and myriapods, have a history that stretches back even further, to an age when the land itself was a new frontier, barren, vacant, and ripe for conquest. Both of these animals did, at one or more points during their tenures, attain sizes far beyond their modern-day counterparts. Multiple species of scorpion could grow to nearly a meter, and the millipede relative Arthropleura armata was longer than a man is tall. But what about spiders? Is there any evidence that they, sometime in the depths of their evolutionary history, reached similarly huge dimensions? Well, let's take a look at the biggest fossil spider that the bowels of the earth have yet unveiled. A publication in 2011 detailed the discovery, naming, and description of what remains to this day the largest prehistoric spider uncovered thus far. It was found in China, in sediments dating to the middle of the Jurassic period, approximately 165 million years ago, and was dubbed Nephila jurassica. And surprisingly little about this spider's appearance and possible behavior needs to be left to the imagination, for spiders of similar overall appearance are alive today, in the tropics and subtropics all over the world. And here, in Brisbane, they are so common and conspicuous that they could more or less be regarded as part of the scenery. Golden orb-weavers are encountered on such a regular basis that it's easy to overlook just how spectacular they are. Their luscious golden webs, glimmering in the morning sun with a beauty beyond our finest woven crafts, make for a sight truly stunning. Yet all the splendor of the web holds not a candle to the spider that rests upon it. These are the largest orb-weaving spiders in the world, with some species reaching leg spans of nearly 20 centimeters. But how does the Jurassic spider, the biggest prehistoric spider we know of, stack up against these graceful giants? Surprisingly perhaps, not to any noteworthy degree. With a body length of around 2.5 centimeters, and front legs around 5 centimeters long, its dimensions are roughly on par with those of many modern golden orb-weavers like this Trichonephila, and it's positively dwarfed by the bigger species like Nephila. So while it's tempting to assume that living animals are far outsized by their prehistoric counterparts, that does not, at least as far as we know, seem to be the case for spiders. The ancient spider from Jurassic China was thought to be of very close affinity to golden orb-weavers, hence its placement in the modern-day genus Nephila. The spider's size, and the dense brushes of long hair at the ends of the tibiae, align with the anatomy of living golden orb-weavers. But despite the surface-level similarities, the animal's classification as part of the genus Nephila, or even within the wider family Nephilidae, was soon to be questioned. Not least because the apparent occurrence of a modern-day genus in sediments dating as far back as the Middle Jurassic seemed more than a little surprising. And the spider's age wasn't the only source of doubt for its classification as a Nephila species. Though this animal on the whole bore a strong physical resemblance to modern Nephilids, more thorough examination has made evident a number of subtle but noteworthy differences. For one, the fossil remains of Nephila jurassica showed evidence of a cribellum. This is a flat, plate-like structure covered in thousands of tiny spigots, which is used to create a soft, fuzzy form of silk known as cribellate silk. Many spiders possess and utilize a cribellum, but golden orb-weavers are not among them, which would make Nephila jurassica quite the anomaly if it were indeed part of this group. Another feature of relevance is the cheliceraal boss, a small but prominent bump situated at the top of a spider's mouthparts. In all known golden orb-weavers, the cheliceraal boss has a striped, or to use the technical term, striated appearance. Indeed, a striated cheliceraal boss is deemed a key defining feature for the family Nephilidae, yet Nephila jurassica shows no evidence of this. Looking at things on a broader evolutionary scale makes the spider's initial classification as a nephelid even more dubious. By analyzing the mutation rate of genetic material in living nephilids and extrapolating backwards, a technique dubbed the molecular clock, researchers were able to gauge the approximate timescale of the group's evolution and diversification, and concluded that it was most likely that the nephilids originated around 40 to 60 million years ago at most. So that presents another significant challenge to the idea that Nephila jurassica was a golden orb-weaver. How could it have belonged to a group that had yet to even exist for another 100 million years? So it goes without saying that things really weren't adding up with Nephila jurassica's supposed nephilid affinity, and another fossil discovery not long after well and truly sealed the deal. The original specimen of this spider, as detailed in the 2011 description of the species, was a female, and for a time that remained the only fossil of the animal known. But just a couple years later, the same locality yielded the remains of another large Jurassic spider, this one a male. Anatomical similarities with the original female specimen of Nephila jurassica provided reason to suspect that this was the same species, and its discovery heralded the final nail in the coffin for the spider's dubious classification. The structure of the male's reproductive parts, the pedipalps, were found to be markedly different from those possessed by modern nephilids. And there was another, much more obvious discrepancy too. Nephilids, especially the genus Nephila, are noted to exhibit some of the most extreme examples of size disparity between males and females in the entirety of the animal kingdom. Yet in Nephila jurassica, the two sexes are much more comparable. Thus it was left beyond reasonable doubt that this Jurassic orb-weaver's initial placement in the genus Nephila was erroneous, and the spider was thus reclassified as Mongolarachne jurassica, the name it bears to this day. But if Mongolarachne wasn't a nephilid, what then was it? Well, the publication that first called the spider's original classification into question, and the later one that just about settled the matter, both put forward the same conclusion. Mongolarachne, it's proposed, was a member of a grouping called the orbicularians, which contains many familiar modern-day spiders, including widow spiders, orb-weavers, net-casting spiders, and the strange, entirely non-venomous Ouroboros. Nephilids are also part of this broad group, but Mongolarachne is no longer thought to have been of close affinity to them, instead sitting nearer the base of the orbicularian family tree, of more distant relation to the nephilids than even the Ouroboros and netcasters. But Mongolarachne's identity crisis seems to have been contagious, for while its classification hasn't been further revised since its new placement as a stem group orbicularian, more recent research has now called into question the validity of the orbicularians as a proper taxonomic group. The orbicularia was erected to accommodate the two main groups of spiders that construct orb webs, the Araneoids and the Ouroboros, alongside their close relatives. It was thought that orb webs were a derived feature that arose relatively late in spider evolution, and that a roaming, hunting lifestyle as exhibited by spiders like huntsmen and wandering spiders represented a more ancestral state. However, more recent studies, especially in the field of molecular phylogenetics, have since demonstrated that spider evolution was likely much more than a simple progression from active hunters to complex web builders. The dinopids and uloborids, both of which are classified as orbicularians, have, based on genetic analysis, been found to be of closer relation to non-orbicularian hunting spiders than to other orbicularians like arachnoids. These newer findings would, if correct, place a whole suite of non-orbicularians, including huntsmen, jumping spiders, crab spiders, and countless other lineages deep within the supposed orbicularian clade. It also suggests that, contrary to being a relatively novel development among spiders, the advent of orb webs occurred earlier in spider evolution than originally thought, and that further down the line, numerous spider lineages forsook this refined craft in favor of alternative lifestyles. To sum things up in a manner that's succinct and not confusing at all, Mongolarachne jurassica was a prehistoric spider that looked like a golden orb-weaver, was thought to be a golden orb-weaver, then turned out to be not even closely related to golden orb-weavers, but instead a basal member of a much wider group that may not even be valid anymore. Yeah, I have a love-hate relationship with taxonomy. It's fascinating, for sure, but researching it has got to be the worst self-inflicted pain I've put myself through for YouTube's sake since the centipede bite. If you're keen to learn about another prehistoric creepy-crawly with a befuddling taxonomic history, then take a look at this feature about the giant Carboniferous Eurypterid Hippotopterus. And if the wondrous world of modern-day arachnids is something you'd like to delve into a little more, then you are welcome to watch this video about the ever-so-bizarre scorpion-tailed spider. And of course, don't forget to subscribe so you won't miss out on any future content. Thanks for watching, and I'll see you next time.